Hey, we're at Conglomerate Falls along the Black River in Gokubek County, and this whole stretch is what got me interested in the Copper Harbor Conglomerate and redefining it as a unit. Because as you can see here, look, that's all conglomerate. And this is we're near the bottom of the formation here. The beds dip generally north, the river goes north. So as we go north, we're going to get the younger and younger rocks. This is the basal member. And here you can see where the overlook is. That's volcanic units in it. And the Copper Harbor Conglomerate in this area, that is the only appearance of volcanics. It's probably some of the oldest of the lakeshore traps. But as you can see, this is all conglomerate here. There's very little anything else in here. There's no sandstone beds. It's a class supported conglomerate, and it's there, right in front of here, the reddish, and then back there are the volcanics. So we're gonna go upstream and look a little more at it. Okay, we're at Potawatomi Falls now. This one is north of Conglomerate Falls where we just were. Here, the rock is still predominantly conglomerate. There's still almost no sandstone in it. It's class supported. There's no lava flows here either. We're north of that. We're going to go to Gorge Falls next, but this is still the lower member of the Copper Harbor Conglomerate. Okay, so we are just south of Gorge Falls, which is actually that bit over there. We are north of Potawatomi Falls, and if you look at the rock here, you can see a little difference in it. You start to see these sandstone beds that become common. The sandstone beds that become common here, and actually the clasts actually get bigger. What you see is, as we're at Potawatomi and Conglomerate, you don't usually see boulder size. You see more calcite in between the cobbles. There's sandstones. Sandstones become more common. This is the second member right above the previous member of the Copper Harbor Conglomerate. Okay, we're at Sandstone Falls now along the southern edge. Sandstone Falls is a set of gently rolling waterfalls, not like the other ones which are steeper. And here we're near the contact between where that second member we were just at and the third member begins. There's an unconformity here. I'm not actually standing on the contact. It's just a few dozen feet south of me. The water's too deep. But here you see some changes here. In this member, the conglomerate and sandstone looks a little purplish. It goes from reddish brown to purple. The sandstone lithology and cobbles don't really change much. The cobbles here and the conglomerate, they're smaller. You don't get any boulders in any of this. But you start to get thicker sandstone packages in here. And this is that third member higher in section. The trend is still the same. You get a lot more sandstone. North of this is Rainbow Falls. We're not going to visit it because we don't really have time, but it's pretty much all sandstone with just little cobble lags in it, and it's reddish in color. It looks a lot like the Frida actually, but that's the uppermost member which we're not going to visit today. Something else you see here are little potholes. These form similar way to pothole as they do at Potholes Nature Reserve in Ontario. They're just a lot smaller, and like I said, the sandstone here being finer, it's easier to cut into. If a cobble gets caught up in there, doesn't move, starts spinning because the water flows, and it just cuts down until either it's freed or disintegrated. I hope you can hear this, but we also start to see a lot more sedimentary structures in here than we do in the lower two members, like ripple marks, more defined bedding planes. The reason why this is purplish and gray is because it has a lot more hematite in it than the lower members do. And then you see some lag, and then see here you get the sandstone beds. You can see beds, and then they have cross beds, both trough and planar within them, and then boom, you get a contact and you get more conglomerate right here. Unlike the previous two members where the conglomerate dominates over the sandstone either is non-existent or in thin lenses, long lenses, here the sandstones, as you can see, are much thicker here, and you can see the conglomerates here. The conglomerates here tend not to be more than 10 feet thick. I've seen some conglomerate units about 15 feet thick, but they're generally less than 10. And something else here, since we have all the sandstone, the lower two members are mostly influenced by alluvial fan deposits. These conglomerates are still alluvial fan deposits, but the sandstones are more fluvial influence, and you can tell that by the cross bedding, which we didn't really get in the lower two members even when sandstone was present. And here you can tell there's a slight local erosional unconformity, and then you even have the cross bed of the conglomerate. So we have a stream to alluvial fan influence in this member that we didn't have in the lower two. What you basically have here is the river follows dip, so it goes almost north. I mean, dip does vary in its direction, but it's generally north. But you'll see you'll get some side flows, and then you'll get a part that follows strike. See, because you can see the dips here, but that's following strike. Okay, another feature about this member that isn't present in the lower two are these enormous ripple marks. There's no ripple marks in the lower two in the sandstone units of the lower two members. This is sandstone, and these ripple marks are just random. They're very asymmetrical. Obviously, you can tell water flow by the crests was this way, but which is really close to dip, the present dip. So yeah, you get these big ripple marks. That's something you don't see in the lower two members. You also get them in the upper member we're not going to visit today. Here's a bigger pothole, and this one still has the rock that carved it in the bottom of it. Here's another awesome pothole with that isn't enclosed. This still has the cutting rock in it too. You can tell, got the kind of a big pothole and then a little one recessed into it. Here's the bigger one, here's a little one. I don't think this rock did any actual carving. It might have though. It's igneous. It looks like it's a granitic rock, so it's really hard. This is definitely one of the cutting rocks, and probably those smaller rounded ones right there.
Is that a tick?
This location is the thickest set of alluvial conglomerates. And you got the sandstones there, conglomerate way in the distance, and the sandstones continue, and then as you can see, I mean, they're all dipping this way. So this is the thickest conglomerate unit I've seen in this member. This one, I haven't actually measured it, but just by looking at it, my guess is it's somewhere in the order of 40 feet. Like I said before, most are less than 10.